today we are learning about surface area. Surface area is the area of each surface of a figure added together. It's that simple. But I want to show you guys how to think about it to give you some visualization tips. So I'm going to take you to a website. On this website, you'll notice that they have the three-dimensional figure rotating around, and then over to the bottom right, they have the net of that figure. Net means when you flatten it out and you look at all the sides. So here we have a rectangular prism, and you can see all the sides of a rectangular prism. For all rectangular prisms, the front and back will have the same area. The side and side will have the same area, and the top and bottom will have the same area. For all prisms, bases have the same area. That's the definition of a base. With a rectangular prism, any pair of sides could be considered bases. So notice that here we have two bases. In this case, we can think of it as the top and bottom. And then all the other rectangles wrap around that top and bottom. And those would be the sides. In this case, we have a triangular prism. The shape of the bases are triangles. So we have two triangles. And then we have rectangles that wrap around the two triangles. In the net, you can see those bases and the rectangles that wrap around the bases. The shape of these rectangles are determined by the lengths of the sides of the bases. So in this example, I can't tell for sure if that's an equilateral. It looks like it's an equilateral triangle or an isosceles triangle. If it's an equilateral triangle, all the sides would be congruent. That would mean that all of these rectangles would have the same area. If this was an isosceles triangle, then two of the sides of my triangle would be congruent, which would mean that two of the rectangles would have a congruent area. If we had scalene triangles as our bases, then all the rectangles would have different areas. So here we have a cylinder. So imagine like a cup. Imagine a cup or a glass, that you drink out of. A cylinder is made up of two bases that are circles, and then you have the middle, which is basically a rectangle. So this is what it looks like when it unrolls. It's basically the circumference of a circle. See the circumference of the circle? Is the base length of your rectangle. The rectangle is the middle piece of your cylinder. So a cylinder is made up of two circles and a rectangle. So you can see an example here. It's made up of two circles and a rectangle. The area of the circles is based on pi r squared. The area of the rectangle is based on the area formula base times height. But the base is the same thing as the circumference of a circle. So let's go back and look at that example we saw again. So again, here is the base, the length of the base of your rectangle is the same as the circumference of the circle. So we're going to figure out the surface area of this first net. This is a net of a triangular prism. And each of the areas have already been found for you for each of the sides. So go ahead and find that. So when you add up all the areas of all the sides of your triangular prism in this example, you get 64. And it's going to be units squared because we're working with area. It's basically the same thing as the area of an irregular figure. You just find all the areas of all the shapes and put them together. In the next figure, we get 42 when we add together all of our sides, 10, 20, 32, 42. Notice in a rectangular prism that opposite sides always have the same area, whereas in a triangular prism, the only two sides, or any other kind of prism, the only two sides that for sure have the same area are going to be the bases. Sometimes the rectangles will and sometimes they won't, depending on the shape of the bases. So here's a rectangular prism. Here in this example, you don't know the areas of any of the 6 sides. So it's up to you to determine the areas of all 6 sides and add them together. So give that a try. What would be the area of the bottom and the top of this particular prism? The bottom is 12 centimeters squared because it's going to be 4 times 3. And so the top is also 12 centimeters squared up here. This area is also 12 centimeters squared because it's 4 by 3. The front is 8 centimeters squared, the 4 by 2 here. And so the back is also 8 centimeters squared. Each side is 3 by 2 or 6 centimeters squared. All right, so here we can see the work. You just find the area of all 6 sides and add them together. Now there's obviously a shortcut with your math, and you can see that here. If one side is 8 and you know the other one has to be 8 as well, you can just double it. One side is 12 and the other is 12, you can just double it. So you can do that as well. You can also do 8 plus 12 plus 6, get that sum, and then multiply that by 2. So as far as doing the arithmetic, there are several ways to approach it. The important thing is you need to know that for any figure, you're adding up all the sides, all the areas of all the sides to find the surface area. So here we have a triangular prism. So the 2 bases are triangles. They're scaling triangles, which means that they do not have the same lengths on all 3 sides, which means we're going to have 3 sides that are rectangles, and each of the 3 rectangles will have different areas. We're going to find the area of the 2 triangles and the 3 rectangles and add those together to get the total surface area. We know that bases always are congruent areas, so the 2 triangles will have the same area. The area of our triangle is 6 because 3 and 4 are base and height, so we multiplied 1/2 times base times height. And since the area of the one triangle is 6, the area of the other triangle is 6 as well. So the area of this left rectangle is 30 because it's a 3 by 10. The right one in red here is 40 because it's 4 by 10. And then the back rectangle is 5 by 10. Back here, this one right here. So we're going to add up 6 plus 6 for the 2 triangles plus 30 plus 40 plus 50. So notice how I draw out all my sides to help make sure that I'm getting the area of all 5 of my sides. I make sure I use my correct formulas, and then I add together all the sides. My units for surface area are always units squared. So this is 132 units squared. It's just an area of a figure, so it's units. This is a square prism. The base shape, of course, is a square, so we're going to have 2 squares with the same area of 9. 3 by 3 is 9. And then all 4 of our rectangles are going to be 4 by 3s. So we're going to have 4 rectangles with an area of 4 by 3, which is 12. You can simplify your math if you'd like into multiplying the base area twice and then adding that to the area of one rectangle multiplied 4 times to get 66. And this, again, is units squared because we're dealing with total area. So as we saw earlier, the area of a cylinder is going to be based on the area of 2 circles plus the area of a rectangle. So you're adding a circle, the area of a circle plus the area of a circle plus the area of a rectangle. Now this gives us a formula that we're going to be using. And really all you have to do, I'll give you the formula on the test, all you have to do is plug in your radius in 2 places in your formula and plug in your height. And you have to know how to use your calculator, and you can do it. But the other piece you have to know is where the formula comes from and be able to explain it to me. So let's look at that. So we have pi r squared in 2 places because we have 2 circles. So pi r squared plus pi r squared, that sum right there is 2 pi r squared. It's like x plus x is 2x. So the 2 pi r squared comes from the fact that we have 2 circles. Then we have to add the area of the rectangle. So the way we determine the area of the rectangle is base times height. Well, in this case, the base of our rectangle, the length of that base is the same as the distance around our circle. Perfect. 2 pi r, which is the length of our base of our rectangle, so 2 pi r right here, is going to be the length of the base of our rectangle because it's the circumference of this circle. Circumference is the length of a circle, and you can unravel that length to get a line segment. So the length of the line segment that is your base is the circumference of the circle. And we saw that when this cylinder unrolled. We could see that the length that is the base of our rectangle is the same as the circumference of our circle. So when you find the area of this rectangle right here, it's 2 pi r, circumference is 2 pi r times the height. 2 pi r times height is 2 pi r h. So we find the area of the rectangle here, which is the base times the height, 2 pi r times h. That gives us 2 pi r h. And we add that to our 2 pi r squared. And that gives us this formula here. So let's just write our formula down, plug in the numbers for r and h in our formula, and solve for the surface area of this cylinder with a radius of 2 and height of 6. So the surface area of this cylinder is 100.5 rounded to the tenths, and you just plug the numbers straight into your formula like you see here. You don't need parentheses or anything. Order of operations will be taken care of. Here's a word problem. The picture represents a storage tank. If you want to paint the storage tank and a can of paint will cover 50 meters squared, how many cans of paint are needed? Go ahead and try that. So the first thing I'm going to do in this example is write down my formula for surface area before I put any numbers in. So I'm going to write down surface area equals 2 pi RH plus 2 pi r squared. Now it doesn't matter what order you add in, right? Because it's like saying 1 plus 2 equals 2 plus 1. So I just happen to do 2 pi RH first plus 2 pi r squared. I know that my radius is 6, so everywhere I see an r in my formula, I'm going to put in the number 6. And you'll see that here and here. And everywhere I see h, which there's only one h, I'm going to put in a 5. And you'll see that right here. So I rewrite my number with my substitution step. I put it straight into my calculator exactly as it looks, and it gives me 414.7 rounded to the nearest tenths. So I know that 50 cans are 50 meters squared, so 50 meters of my cylinder, however much that is going to be covered by 1 can of paint. Okay, so I want to see how many of these cans do I need. If I have 414.7 meters squared that I need to cover. So I'm going to divide 414.7 by 50, and that's going to give me 8.2 something, something, something. Well, if I get 8 cans of paint, that's not enough paint to cover the whole thing. I still need another can of paint to completely cover it, even though I won't use the whole can. So I'm going to round this up to 9